Students, today we are going to discuss about the amperes circuit law. So in electrostatics, the ampere circuit law can be written as E dot closed integral E dot dl is equal to 0. But in magnetostatics, the ampere circuit law is B dot dl is equal to 0. B dot dl means the magnetic induction in a line element around any closed path is equal to 0. The closed integral of magnetic induction over a small element is equal to 0. So in order to derive that, so let us consider a current carrying conductor, a long current carrying conductor. Consider a wire which is carrying some current I. So according to right hand thumb rule, around any current carrying conductor there may be a generation of magnetic field. So around this a magnetic field is generated. So if you want to calculate the magnetic field at any point, so we should draw a tangent at that particular point, then we will get the magnetic induction. So let us consider this circular path is having radius r. Consider a small element which is making an angle delta theta. This small element is like a straight line having length or arc length delta L. So in order to derive the ampere circuit law, let us consider a long current carrying conductor. Around any current carrying conductor there may be a generation of magnetic field. If you want to calculate the magnetic field induction, we should draw some tangent at that point. So let us consider an element dl or delta L which is making an angle small angle delta theta with that of the origin. So this magnetic induction generated at that particular length element delta L can be written as B dot dou L is equal to, according to magnetic induction, the magnetic field induction generated due to current carrying conductor, a straight current carrying conductor, is mu I by 2 pi r. So this formula you have already derived in your degree textbooks. For any straight current carrying conductor, the magnetic field generated at any particular point is mu I by 2 pi r, having the radius of this loop as r. I is the current carried out by that conductor, mu is the permeability, and pi is constant. So if you substitute this value, B is mu I by 2 pi r. So here delta L is almost a straight length element. So if you consider sin delta theta here, if you consider from this diagram, calculate sin delta theta. What is sin delta theta? It is delta L. If you consider this as a hypotenuse, this is r, then delta L is equal to r sin delta theta. Since this angle is very small, we can equate this sin delta theta is nearly equivalent to delta theta. So in place of delta theta, delta L, we can write as r delta theta. So this is the derivation for r delta theta. So consider this as a right angle triangle. From this right angle triangle, calculate sin delta theta. Sin delta theta is equal to opposite side by hypotenuse, that is r. So from this we have calculated delta L. So delta L is r delta theta. Then this equation will become mu I, r get cancelled, delta theta by 2 pi. So note down this one. Next, for entire loop, for this total closed loop, that is for the closed path, B dot delta L can be derived as closed integral of mu I by 2 pi into delta theta. Mu I 2 pi are constants, so closed integral of delta theta. So if you repeat this small angle by 180, that means this angle, next this angle, this angle, total circle is 360 degrees, but this, if this small angle is rotated by 180 degrees, then we will get the total circular path, that is this closed path of delta theta is B dot dl is equal to mu I by, is equal 0 is not, what is this value? So mu I by 2 pi into 2 pi. So here 2 pi get cancelled. We get mu I. So this is the amperes circuital law. Closed integral of B dot dl is equal to mu I is the amperes circuital law in magnetostatics. This is the total derivation.